Good morning, good afternoon, good evening, wherever you are, and glad to be here on the Leap Day. Thanks everyone for joining me, and what I'm going to do in the next 55 minutes or so is kind of do an overview of Couchbase and how do you use it using Java. It's pretty straightforward. Using a few Java files, you can be up and running pretty quickly. My name is Raghavan Srinivas, but a lot of people have a tough time pronouncing my name, so I go by Rags. And I work as a developer advocate at Couchbase. So I've spoken at several different conferences. I've also taught some undergrad and grad courses. I've worked as a technology evangelist for Java and Sun for a long time. But I'm still trying to understand and work more effectively on, on distributed systems in general and Java in general. And I have a philosophy that it's better to have an unanswered question than an unquestioned answer. And I really don't know what I mean by that, but essentially, if you have more questions towards the end of the talk, I think I've achieved my objective. So the agenda for the remaining part of the program is, we'll take a brief look at distributed systems, and then, look at the Couchbase server itself. How do we get started with Java? We'll look at a bunch of demonstrations, actually, and a case study. And actually, those slides, have come from the company that implemented the case study. So that's a real life case study. Then I'm going to follow it up with some resources and summary, and a roadmap of where we're headed. So that said, let's get started. So whenever we are designing distributed systems, a typical NTR architecture, you start off with something in the front end, like web tier, something in the middle end, which is the business logic and the business tier, and then you have the data tier, right? And typically, what ends up happening is that if you start off with kind of a monolithic approach, you don't tend to get performance like you want, and typically what ends up happening is you add some load balancers, you add web servers that effectively use the load balancer, and then on the data tier, you have to end up sharding your data in such a way that your data is distributed on different databases or on different nodes. So what ends up happening is that, despite a meticulous design, it's hard to keep up with some of the topology changes. So if you add a new node, or if one of the nodes goes away, then typically what ends up happening is that your system may not end up performing like you would want it to. So one of the answers to this is that you can add more servers for the application tier, and typically that tends to scale pretty well. So what you're doing is you're kind of doing some horizontal scaling. But on the data side, if you want to scale up, you kind of hit a wall with respect to performance, because at some point, you really can't get the throughput and performance that you desire. So typically what ends up happening is that, it's easier to scale horizontally than to scale vertically, and that is really the goal of many of these distributed systems that are in vogue today, including Couchbase. I like to simplify things, perhaps oversimplify to an extent, right? Many of you, I'm sure, have used hash set and hash maps and so on. And the idea behind hash set, hash maps, and so on is, you set a value to a particular key, right? And when you do a get, it returns a value, as simple as that, right? Of course, this is very easy when you're doing it on a single node. what happens, when you're doing it on a cluster, what happens when you have so many keys that, is probably not going to fit in your memory, and really what happens when, nodes are coming in, coming out, going out, and so on. So your topology is kind of changing constantly, right? So a simplistic view of Couchbase is that, it's really a distributed key value pair. Your APIs continue to remain exactly the same, but underneath, the infrastructure takes care of, hiding all the complexities of a distributed system. Many of you have probably seen this, and you've experienced it firsthand as well. These are the 8 fallacies of distributed computing. Essentially, whenever you want to take a system that's not distributed and you want to make it distributed, a lot of times what happens is you tend to make some assumptions which typically come back to bite you later. At least that's been my personal experience. Just taking the example here of your topology doesn't change. Obviously your topology is going to change. Especially if you're relying on scaling across, right? Horizontal scaling. Transport cost is 0. That's a fallacy as well, because again, even with Couchbase, you probably want to be, using your client, typically on the same subnet as where your Couchbase cluster is. So the idea is that you're going to program to the same set of APIs. You're going to use the simple getters and setters, right? The setters and the getters, and the infrastructure is going to take care of of hiding the complexity. So the goal is that if you're using Couchbase and your performance curve kind of tends to go up exponentially, by adding more servers, what you can do is you can kind of tend to flatten that curve, maybe linearly or at least close to linear as possible. So let's move on to the next part, which is the Couchbase server. At this point, I want to just take a brief moment to see if there are any questions. Any questions?
No questions have come in yet, Rags, so we'll let folks know. Folks, if you have questions for Rags and what he's talking to you about, please type them in the group chat, and we'll make sure he sees them. Back to you, Rags.
Okay, thank you, yes. So, the data flow is pretty straightforward. What you're going to do as, when you're using the client libraries, you set the value for a key, and the client library is going to hash it to the appropriate server. The server is going to receive that key with the value, and the Couchbase server really takes care of persisting that key value pair. It's going to take care of replication, it's going to take care of persistence, and so on. Okay. So what exactly happens under the hood is that the Couchbase server gets a key and the value. It's going to persist it, like I said, and a acknowledgement is sent to the application. The replication happens automatically by the Couchbase server. Unlike many other systems, Couchbase server does not really have the concept of a master slave, so they're all peers. And what happens, when nodes get added and removed, is that the Couchbase client libraries maintain a map of the servers, and they know which server to contact for a particular key, either to get it or to set it. So, you can use it really at very small scale and really at large scale. Here are some examples of that. Zynga, which is a social gaming application, they use Couchbase quite a bit. It's based on Memcached protocol, which is really the gets and sets. I'm going to talk about the roadmap where we are taking some of the features from CouchDB and incorporating them into the next release of Couchbase, which is Couchbase 2.0. Okay, and I'll talk about those features, which are referred to as views. So at this point, you're probably wondering how do I get started with my Java client libraries, right? So it's pretty straightforward. Most of the languages have client libraries for access to Couchbase Server. Obviously Java has client libraries as well. And like I said, if you want to get started with your simple Hello World program, all that you need to do is include the jars in your class path, or just kind of use a Maven project, which kind of incorporates all those dependencies. So essentially, what the client libraries do is they have an API, and they essentially take care of the connections. Either implementing the SPI Memcached protocol, the Memcached protocol, or the CouchDB features that we're going to talk about pretty soon. So, again, I use my Couchbase client libraries, and I'm connected to a 4-node cluster in this case, and all that I'm going to do is I'm going to continue to interact with the nodes, and if a new node comes online, I get a cluster topology update, and the maps are going to be updated on the client library, and from a developer perspective, from a user perspective, you don't really have to do anything, to make this happen. So essentially, when a node gets added or when a node gets removed, you don't really have to do anything, and the persistence and the replication and all those features happen automatically. Most of the operations, and they are very simple operations, like I said before, get, set, and we'll look at one more, which is the compare and swap operation in a brief second. But essentially, using these operations, you can do some fairly powerful things. And most of these operations, they come either in the synchronous nature or the asynchronous. And as you can see here, what I'm doing here is I'm setting a key called key, and setting it to a value. Let's not worry about the expiration time, which is really a TTL, and we'll talk about that, the time to live in a moment. But essentially what I do is I set, I use the asynchronous set, and then what I do is I get back a future. The operation future is really, extends the future object of Java. And what I do there is, I use the future object, and at some point I'm going to block and see if our set succeeded. So what you want to do between the part where you set the value and where you kind of check for the return value, you can essentially go ahead and do some operation which is asynchronous in nature, right? So I look at the value, and then depending on whether I get a true or a false, I basically say whether my set succeeded or my set failed, and so on. Okay, and a lot of times you can also kind of combine these operations. So if you just do a get on the return value, you can be blocking. So you can take an asynchronous operation and essentially turn it synchronous by getting the value, and in which case you will block until that operation completes. There are a number of different operations, very simple operations, like store, add is when you store a document. Typically, and you'll see this in a second, what you will do is the examples that we saw so far were setting a very simple value, but you can really store anything that you want there, A lot of times what you end up doing is, you store the entire JSON document, because you can really rely on the fact that, you can extend the JSON document and make it a little bit more of a flexible schema. And we'll see that, with some examples as well. You can set, store the document. You can retrieve, documents by doing a get. You can do a get and touch, which will update the, time to live, and we'll talk about what that means. There are some bulk operations as well, and essentially what this does is it allows you to specify a map, of the keys, and you can essentially write all those keys at the same time. And that way you can minimize some of the traffic, network traffic. There are a number of update operations as well, append, prepend, delete, compare and swap we'll see in a bit, and then replace and touch. So what I'll do at this point is, I'm gonna go ahead and do a quick screen share and do a quick demo. Okay. So what I'm going to do is I'm going to open up my Eclipse and show you it's pretty straightforward to incorporate Couchbase into your client libraries. Okay. So what I'm going to do here is I'm going to open up. I'm going to open for import.
Rags,
okay.
Hi. We're not able to see your screen. Can you click the screen share button and share it from the beginning?
Thank you.
Thank you.
Okay, I've launched it. Yeah, it doesn't look like it's working. So what I'll do is I'll quickly log out and log in.
And actually, don't do that. Let's just take a look here. We're seeing your slides, the slides in the console. If you click that screen share button and then choose yourself and launch the screen share, let's see if it works that way.
Okay.
And again, folks, while we're setting up the screen share here, if you do have questions for Rags and what he's showing you and talking to you about, please don't hesitate to put them in the group chat for us, and we'll make sure Rags answers those when we get to Q&A.
Okay, that doesn't seem like it's working. So shall I log out and log back in?
Sure, let's give that a try.
Okay.
Folks, sorry, please hang on. Hang with us here. We'll get this resolved in just a moment. Rags has a great demo, live one to show you here. We want to make sure you see it. So please stand by.
Okay, so what I'm going to do is I'm going to import a Maven project into my Eclipse. And all that I'm going to do is I'm going to import. And I say existing Maven project. And basically what I'll do is I'll go into the appropriate directory. And I have a simple demo here. And I'm going to open that up. Okay? So pretty straightforward. I'm going to take a look at the project. Okay, you'll see the POM file here. And let's take a look at the POM file itself. Essentially, I'm getting the Maven repository from files.couchbase.com Maven 2, okay? And then I have a bunch of dependencies that I don't really want to include and so on. So once I have that, I'm pretty much ready to run this, okay? So, there is really not a whole lot here happening, but, we can run it for the heck of it. So essentially what I'm doing here is I'm saying, get me a connection to HTTP localhost 8091. 8091 is the default port. And then what I do is I add it to the URIs. So I'm adding the local, which is the local host, and I'm adding it to the URIs. I can specify more than one URI. Obviously, it's an array list. And then I basically say I want a connection to that particular URI to the default bucket, which is always available by default, and really there's no password. And all that I'm doing here is I'm setting key, with no TTL, and we'll look at what TTL is in a second. And I'm saying hello leap day, and I'm getting the key, which is essentially what I said just a moment ago, right? So pretty straightforward. Not, all that I need to do is I'll run it as a application, and hopefully, I should get back the hello leap day. Okay, so pretty straightforward. It tells you a bunch of things, about if the connection was successful and so on. It tells you that it got a new IO connection and so on. Okay, so this is pretty straightforward, very easy to really get started, with Couchbase. But all that I'm doing here is setting a string. So what we'll do is now switch to a little bit more complicated example, but again, pretty straightforward. So what I'll do here is, I wrote this last week, because last week was President's Day. And essentially what I do in this particular program, is I use the Google JSON library, and I take JSON and persist it, in Couchbase, okay? So if you look at, the example here, what I'm doing is I read the particular file, okay, and this is where I do the read, okay, and then what I do is I take each entry and I persist it. In Couchbase, and basically I'm saying 200. I'm going to specify it as 1200. Okay, so that it lasts for 1200 seconds, which is really 20 minutes. I think there should be plenty of time for the demo. And I use the key, which is really the entry.presidency. Okay, so what we can do is we can take a quick look at how this JSON file looks. Okay, so essentially there is a presidency, a name, a Wikipedia entry, and so on and so forth. Okay. So what I'm doing is, I'll go back here, and I'm writing it into, this particular URL. That's where the, the Couchbase server is running. Okay. So, again, pretty straightforward. I'm going to run this. Okay, and as you can see here, it wrote all the, the precedents. Okay, so if I go back and take a look at my, at the, the particular URL, all that I have to do is provide the administrator the user ID and the password, and I can take a look at this. Okay, so this is the admin console that comes by default. It shows you what are the data buckets that were there. And here's my president's data bucket, and it has, these different keys and so on and so forth. Okay, so if I take a look at the views and I, just try to create a development view, and this is a feature that's really, with Couchbase Server 2.0, so I'm going to call it something else. Okay, and I can take a look at this. And take a look at the ID, or let me do a preview of a random document. Okay, so I'm looking at default, which is not the correct thing to do. So what I'm going to do is I can take a look at development view. okay? And you can see, there are different precedencies here, okay? So if I do 44, I think I should be able to look that up as well, okay? This is pretty straightforward, but what happens, if I want to be a little bit flexible with my schema? Let's say I want to add, in this particular case, what I want to do is I just want to look at, the record, and I want to add a field called, I don't know, I'm going to call it as notable. Okay, for, this is not going to, don't take this by any means as my, political leanings, okay? So I'll try to stay as non-controversial as possible. So this is kind of the notable, and here's a notable as well, and this will be okay. So I've added these two, and notice that I didn't really add this notable field to every entry there, okay? But the idea is that you should be able to still work relatively okay, by adding a field and still be able to make sense of the data. Okay, so I'm going to add the notable. Okay, and now what I'm going to do is I'm going to try to persist this. Okay, and that's not a good sign. Okay, so that's the JSON file, and I do that. Take a moment here. So I need to add a comma there, make sure that everything is working. Now go back, and so this is a live demo. Okay, and I run it, and you can see that for some of these fields, you will have the notable entry. Okay. So you can see here there is a notable entry, and there is a notable entry here, whereas there is really nothing in here because I didn't really add anything, to Bill Clinton or to George W. Bush Sr. and so on. Okay, so hopefully that kind of gives you an idea of how you can deal with the quote unquote schemaless databases, or really more schema change tolerant databases. Okay. So with that, let me get back to the presentation. Actually, let me do one more demo while we are here, okay, and I'll talk about that in a second. So this is an example of what is referred to as optimistic concurrency, and typically what you do with, if you have to implement concurrency is you grab a lock and you hold on to that lock, until you're done, with a critical section, right? But what Couchbase does is it provides something called as optimistic concurrency, in the sense that what you do is you go ahead and assume that there are no synchronization issues, and just go ahead and write it. And if somebody else changed the value by the time you got it and by the time you set it again, then what's going to happen is you're going to get notified of that by this value called CAS, or the compare and swap value, and if you get notified on that, then you take some corrective action. So that's typically referred to as optimistic concurrency, and you can see here that's exactly what this is doing. So basically, again, I'm using localhost, and what I'm doing is I'm getting a CAS value, okay, for a particular key. And then what I do is I kind of simulate some work here, so I go to sleep. And then what I do is I set the value and get the CAS, at this point. So what happens is if nobody has, has set the value between, for example, line 45 and line 57, then what happens is my set is going to succeed, okay? But if somebody changed it, then it is the application's responsibility. It's really the onus of the application, to take some corrective action. Okay. So what I'm going to do here is I'm going to run this, and obviously when you're running it, as just one client, the set is going to succeed. It's going to take a random time to wait, and everything is hunky-dory. But now what happens when another thread or another client, is going to try to set the same value, right? So now you should see, a bunch of failures on one of the clients, okay? So you can see that, since it's completely random, some of them succeeded, and when this succeeds, the other one fails, right? So if I go back here, you'll see that this is all failing, and now it succeeded again, and this is failing, and so on. So what you do is, you let the concurrency issues happen, and when they happen, you take some corrective action. Okay, so let me stop that, and let me get back to the okay.
Hi there, Rags. We have a couple questions that have come in, so whenever you're ready to take a look at the Q&A. We just saw the demo. It looked good, so back to you.
Okay. So let me push the presentation, and in just a second. Okay. So we saw a bunch of demos. There's another fairly involved demo, which is really a game simulator, and depending on time, we will run that. And essentially, what this is there are three objects: players, monsters, and items, right? Players fight the monsters and grab items, and monsters basically drop the items. Players fight with the monsters and get items. Pretty straightforward application. So this is kind of how a player document looks in JSON, okay? And this is how an item document looks, which basically has a pointer to a player who grabbed that item, right? And then what you have is, the monster document itself. So what I'll do at this point is, start the game, and essentially, I'm going to simulate the game, and we'll see in a little bit that the workload should get started. So this is where the game is running. Okay, and I can kind of look at the cluster, and you can see here, that I have a number of different servers, 2 active servers, okay? And then what I'm going to do is I'm going to add a third server here. This is the third server, and let's see if this works. Okay, that didn't work. But, I don't think that matters. Let me see if I can grab this and add it to okay. So I'm setting up a new cluster as the workload is being simulated, okay? So I'm just going to join a cluster, and I'm going to specify the URL to just make sure that, I don't have the...
Excuse me, Rags. We're getting reports from folks they can't see your screen share.
Okay.
Could you re-share that, please? Thank you.
I will do that. Okay. So essentially what I'm doing here is I'm adding a new node. And you can see that, there's one server which is pending rebalance, and the other servers, you can see that there is some load that's happening, which is essentially the game simulator itself. It's loading, the monsters, the players, and the items, and so on and so forth. Okay, I can take a, a look across, the different servers. Okay, so I can take a look at the server, and you can see, what is happening here by the minute, by the day, and so on. Okay, so as you can see, there's a lot of things happening here, and it's pretty useful, from a programming perspective, to kind of take a look at this. What I'll do here at this point is I will just do a rebalance, and you will see that, despite the, there being load of the cluster, it's able to rebalance. So in other words, it's still able to, take the incoming traffic, but able to rebalance your nodes as well. Okay. So let me go back to the views and see if there are any views. And what I'll do is I'll quickly create a view. Okay, and I'm going to call it players. And essentially what I'm doing here is I'm creating a view where I'm going to look at the level of the players. Okay, and you'll see that in a second. So what I'm going to do is I'm basically using this incremental map reduce, which essentially increments, which runs constantly. And the idea behind this is that it provides you with an index which is not necessarily your key. Okay. So what I'm doing here is I'm taking a look at the level of the player, and I'm emitting that. Okay. So let me save that, and let's look at the results, and then kind of go from there. Okay, so as you can see here, the level is, is pretty random. Okay, what I'll do is I'll say it's got to be descending. Okay, and proceed from there. Okay, and you can see here that it's basically in descending order. So it looks for each player and it emits the level and the doc level, and then what it does is it emits the doc ID as well. Okay. So what I'm going to do is I'm going to make Keith 2491, as the king. Okay. So just make it really high, and then what I'm going to do is I'm just going to show the results, and you can see that the the MapReduce or the view kind of updated itself. Okay. So that's a demonstration of how Couchbase cluster kind of adjusts itself to the load, is able to rebalance and kind of keep going. And also we saw a feature that's going to be part of the next release in 2.0, which is referred to as views, and I'll talk about that in just a second. So let me get back to the presentation. So we saw the game, okay, but really, these are used in real applications as well. A case study of this is the tribal crossing. Kind of looks similar, right? Player can have a variety of plants on their farm, can remove plants from their farm, and see what plants are on other players' farms. Okay, so a very simple game here. So at some point, tribal crossing came to a point where they had to really work on the performance. Caching does not really help because a lot of these are write requests. So if you have to go back, if your cache gets invalidated all the time, that's not going to help you. So after a careful evaluation, basically tribal crossing looked at Memcached and Couchbase, and essentially what they do is they take an object and treat it as a map or a dictionary or a JSON object, right? Which is really what we did, in the precedence example. And then what we do, what they do is they determine a key and really not worry about normalizing it, to the third normal form or whatever that is, right? Instead, what you do is you denormalize it and not worry about normalizing it fully. So you can see here, the player plant list has a list of plants, and all that they are is a comma-separated list of the different plants. Okay, so 201, 202, and 204, and so on. So obviously, the application has to do a little bit more, but I think it makes it much easier, to adapt, to some of the changes in the data. You don't need to do a alter table, which is typically a very, expensive operation. Even in the president's data, you saw that we were able to adapt to some changes, relatively straightforward. Okay. If you want to get the different plants, basically what you want to do is, you want to go through the list of the plants and then, get the plants that's associated with the player. If you want to, I think, add a plant, then what you do is, again, you want to update the comma-separated list, and that really becomes the onus of the application. But again, for the advantage of that is, you can adapt relatively easier to schema changes than being able to do it, in a traditional RDBMS normalized environment. So this is the conclusion they came to. It significantly reduced the cost, achieved significant improvements, and really focused on game development, which is, Tribal Crossing's core competency, right? And really, Couchbase Server took care of the infrastructure. Granted, they had to write some extra code, but I think overall it was a win-win. So with that, let me get to the roadmap, really quickly. Essentially, the Couchbase Server 2.0 is the next major release of the Couchbase Server. I showed the demo. The demo was really based on the Couchbase Server. We saw a view where we emitted, the level of the player, and that was really based on Couchbase Server 2.0. And the idea behind that is, if you want to do something, if you want to query your data, not necessarily based on key, then how do you deal with it, right? So that's the functionality that's been incorporated in 2.0, the indexing and querying function. And all that you are going to do is you're going to use a incremental MapReduce view that you can develop, in development environment and then push into production. And there is also a cross-center data replication, that I don't think we need to talk about here. But from a Java development perspective, this is coming. This will be in the next version of the client libraries. It's pretty straightforward to access that view. So basically, you say client.getView, and you specify the view name, you can get the view, and it works exactly like before. So you can specify a future, and then go back and look at each of the values in the particular view and handle it appropriately. So with that, my last section, which is resources and summary. Hopefully, I've convinced you all to go and download the version of the Couchbase Server. Download the Couchbase Server. There are flavors for all the different operating systems, all the different CPU versions, and so on and so forth. If you want to develop with the Java client libraries, and I hope you will, just take a look at couchbase.com/develop/java/current. It has a number of other examples that, I didn't really have the time to go through in this presentation, including the tutorial, the getting started, and so on. You can get help on the Couchbase forums. We also have a scoop-based Hadoop connector. I didn't really have the time to talk about it, but if you are at the Big Data Conference, which I will be tomorrow, please come by the Couchbase booth and say hi. There are a number of conferences that are coming to a city near you. Chances are that we will be somewhere close to you. Just take a look at the CouchConf World Tour. The Tribal Crossing blog, which is again from the company Tribal Crossing, which I think got bought out by Fable Labs. Take a look at that, and they talk about Memcached and Membase and Couchbase. With that, I reached the end of the presentation. I really want to thank everybody for being here on Leap Day. My name again is Raghavan Srinivas, and the easiest way to reach me is rags@couchbase.com. Rags@couchbase.com, or you can also reach me on Twitter. I'm rags. That's my handle. I really want to thank everybody, and this is the time for I think I have time for at least a few questions.
Hi, Rags. Thank you so much. That was an outstanding presentation. And yes, we actually do have quite a few questions that came in. Are you able to see them in the Q&A tab, or would you like me to read them?
Yeah, I'm able to see them.
Okay.
So let me take the, what is the relationship between CouchDB and Couchbase? I think this was Mike Lamb. Mike, thanks for asking the question. Essentially, a lot of the, maybe what I should do is I should take a step back. Essentially, the company was, the founders came from CouchDB. So Damien Katz, who was responsible for CouchDB, at least in its inception, came from that company. But what has happened is, there are quite a few things that have happened since then. But like I said, the current version of Couchbase has most of its root from Memcached, and we are incorporating some of the features that CouchDB had. Like, for example, views, the indexing and querying functionality that I talked about before. So the way to look at it is, Couchbase is compatible with Memcached because there are a lot of, installations out there which use Memcached, but there are some features of CouchDB that will be, incorporated, in the near future. Okay. So the next question is there an automated deployment process for the MapReduce Vue JavaScripts? And I'm not quite sure, what this question really means, but if it means, can I kind of, I think what you saw when I did my demo was I essentially did, the testing, if you will, with the development subset of data, okay? But if you want to, do the view across the entire cluster, you can do that, pretty straightforward. There is an option there to kind of look at your results across the cluster, okay? So you can look at the entire data available in the cluster, and then finally when you're happy with your results, what you can do is you can take your your MapReduce script and push it from development to production, okay? So when you move it from development to production, you cannot really modify it. So you will have to kind of go through the whole process again. So in other words, you do your development, and then once you're happy with the development subset, then you look at the cluster-wide data. And once you're happy with your cluster-wide data, then what you do is you kind of push it to production. So there is a deployment process, but not quite automated, but you can do it manually. I don't know if that answered the question. So the next question is, when will Couchbase Server 2.0 compatible CouchDB mobile product be available? I don't have the answer to the question. Like I said, the Couchbase Server 2.0 will incorporate some of the CouchDB functionality, but the CouchDB mobile functionality is going to be incorporated soon as well. So here's another question that's really applicable not just for Couchbase, but to an entire class of databases, I would think. Any helpful tips for converting legacy databases to CouchDB? And as you as you have probably heard, many of these NoSQL databases, they are based on what is referred to as the CAP theorem, the consistency, the availability, and the partition tolerance, right? Most of these databases, are partition tolerant, and what I mean by that is, you will be able to distribute it, but they sacrifice either the consistency or the availability part of it. So what you want to do is you want to be able to design your schema or your data model in such a way that you don't have to do some expensive joins. So if you have different if you have your data stored in in different tables, quote unquote, right? It becomes very expensive to join them in real time. So what you want to do is you want to denormalize it, and if your data model is suitable for denormalizing it, I think that's that makes it easier to move from a legacy database to a Couchbase kind of database. Okay. The other thing is, again, what I showed here was a key value pair, right? Very easy to store a document using a key value pair. Now, is your data model kind of amenable, to something like that? That's something that you'll have to look into. If you really need some very strict ACID properties, that a lot of transaction processing systems support, chances are that you may have to work around those, or you may just NoSQL might not be your answer for that. Couchbase may not be your panacea for that as well. Okay, so hopefully that kind of gives you some ideas of how to convert from a legacy database to a to Couchbase or something like that. Is Couchbase client instance thread safe? Yeah, if you're using it from the same, typically what you want to do is you want to use one instance of the client and use that. So if you're using it from multiple clients, typically what happens is you queue an operation to a thread, and really I don't think you're going to achieve a lot of performance and throughput by using the same client instance in multiple threads. And that provided the answer. Are there any more questions? I have 6 questions here. I think I answered most of them anyway.
Yeah, I'm not seeing any additional questions. Looks like you got them all, Rags. Okay. Is there anything you wanted to leave our audience with today before we wrap up?
Yeah, so I want to, essentially try to wrap up on time. The primary takeaway is that, using some of the jar files, you can really get started pretty relatively easily. All that you do is you make a connection to, to the server running on the appropriate port, connect to the default bucket, and you're ready for business. There were a couple of things that I actually, did not talk about, and that was the time to live property. So the time to live and the compare and swap that we looked into, those are simple operations that Couchbase provides. And using those primitive operations, you can develop a fairly sophisticated system. Get, set, and optimistic concurrency using the compare and swap. So what it does is, like I said before, it checks for a value, and if somebody else changed it, then you have to take corrective action. So the the message is very clear. It's fairly easy to get started with the Couchbase client libraries. They're available for different languages. For Java, it's pretty straightforward. Just include the Java libraries or include the main repo, and you're ready for business. You can use NetBeans, Eclipse, whatever your favorite editor is, or if you want to do it on the command line, that's fine as well. And really, what the Couchbase server and the client's libraries do is hide the complexities of the distributed system, like for example the replication, the sharding, and so on. And you don't have to, you don't have to do anything, and the system takes care of it. With that, I want to thank you again, and I'll give you back 2 minutes of the day. And I want to thank Yaz. I want to thank Anna on, from the Couchbase side. They were all really helpful and made this happen. And thanks again.